Hello everyone. In the last video we have seen about the Jacobian. Now here we will be continuing with that, but only thing here we will be using the Jacobian for implicit functions. Implicit का मतलब हमने पहले भी पढ़ा है. Implicit मतलब variables. There should be some relationship which is given between the variables. For example, अगर x y variable है तो उसमें जो रिलेशन दिया हुआ होगा, राइट, एक्स स्क्वायर प्लस वाई स्क्वायर या एक्स प्लस 2y, सो देयर शुड बी सम रिलेशन इन बिटवीन, दे आर नॉट इंडिपेंडेंट. दैट इज मीन बाय इट्स अ इम्प्लिसिट फंक्शंस. अगर जब भी फंक्शन जो भी फंक्शन अगर इस फॉर्म में दिया है तो हम उसका जैकोबियन किस तरह से निकालेंगे. इट्स अ प्रीटी सिमिलर टू व्हाट वी डिड विथ अदर फंक्शन, लेकिन थोड़ा सा जब इम्प्लिसिट हो जाता है तो दैट वन मोर स्टेप्स आर एडेड इनटू इट. So let's see with the example. So here x is given in the term of in the form of u and v. X is a function of u and v, and y is also function of u and v. So you clearly see that u means it's not like that x is completely function of u, or it's not like that y is completely function of v. It's not like separated like that. If you see it clearly, x is function of x and u and v, and y is also function of u and v. So if there is this kind of function, if you see that, then we can say that they are implicit functions. So variables are not independent. So that time how we are going to proceed. So these are the given functions, and we have to prove that j into j dash is equal to 1. Now given equations, we can write it in as it is, and we can label them as equation 1 and 2. So I have taken this here, I called it as x value as equation 1, I took a y value, then I called it as equation number 2. Now to find the Jacobian, what we will be doing, x is a function of xy is a function of u and v. So how we can write the Jacobian is we can write the determinant. Since x y is a function of v, u and v, what we can write is del of x and y with respect to del of u and v. So now while writing the Jacobian, simply we have to take each function and we have to differentiate with respect to each of the variable. So that will be our first line. So x is, we will be differentiating with respect to y. I wrote it here del x upon del u, and x we will be differentiate partially with respect to v, so it's del x upon del v. Similarly, y is also function of u and v, so we will take y and differentiate with respect to u as del y by del u, and we will differentiate with respect to v, so it's a del y by del v. So now if you take the x value and y value, like x value was given u into bracket 1 minus v, and y was given as uv. These were the given values. So you will just expand it, so you will get u minus u into v. So this will be our x value. So if you want to find del x by del u, so we will be differentiating this with respect to x. So you will get x del x by del u. So if you want to find it with respect to u, so this u's differentiation will be 1 minus differentiation of uv, you will be, if you will try to find it out, so v will be treating as a constant, and it will give u's derivative will become as a 1. So you will get minus v, क्योंकि u का derivative with respect to u will become 1, so that's why we are getting 1 minus v. Similarly, what we can do is del x upon del v. So with respect to v, if you will differentiate it, then again, so this equation which we after expansion we got it, we will differentiate with respect to v. So u का differentiation हो जाएगा 0, and with respect to v it will become minus u, because v's derivative will become 1. So this value I have placed in the first row. Del x by del u I got 1 minus v, and del x by del v I got minus u. So this is what I got it. Now similarly, if I will differentiate this y with respect to u and v, so if I will differentiate with respect to u, I will get it as a v, and if I will differentiate it with respect to v, I will get it u. So these are the two values. I can write it in the second row. So I have substituted it. So this is how we got the Jacobian determinant over here. After that, by using the rule of determinant, we will just simplify it. How we can do it? Just by taking a multiplication of this one minus, we will subtract the multiplication of this. So next step, we will be solving that. So by solving, so I have taken the cross multiplication over here and I will simply get in this form. So now after expansion, I can clearly see this minus uv plus uv, I can cancel it out. So j's value will be u. Now next thing what we have to prove is j into j dash is equal to 1. So this thing we got it so far, j's value we have received it, j is equal to u. Now next thing would be we have to find j dash. Now सबसे पहले j dash का मतलब क्या होता है? j meaning what we did is u and v were the functions of x and y. That's what our j was there. So while finding j dash, what we do it, we just do the reverse. In j, what was the given? In the given function, what was given? That x and y were the functions of u and v. So now in j dash, what will happen? U and v will become a function of x and y. So we will write it something like this. So this will be becoming our j dash. So uv will become now function of x and y. So we can write it here like del of uv and with respect to del of x and y. So this will become our j dash. Now since u and v are in terms of x and y, what we will be doing, x, y will be our variables with respect to which we have to partially differentiate u and v. So first function we will take it and we will differentiate it partially with respect to x and y. So u, I have taken it here with respect to x, and with respect to y I have differentiated it, which I wrote it in the first row of the determinant. Now next I will take v, then I will differentiate del v with respect to x and del v by with respect to y, which is del v by del y. Now if you clearly see this here, u we have to find del u upon del x, we have to find del u by del y, we have to find del v by del x and del v by del y. So this given function u should be in the form of x and y, and v also should be in the form of x and y. But if you see the given function, it is given like x is equal to u 1 minus v and y is equal to uv. This is given in something this way. So if you want to find del u by del x, if I want to find del u by del x, this u, this should, I don't want this v in this equation. So I have to remove that v. Similarly, if I have what I want in the second row of this determinant, I want to find del v upon del x and del v by del y. So I want this v should be in the form of x and y. So definitely I don't want this u. So I don't want this u over here. So same way like in x, I don't want this v and this here when I am finding v, I don't want that u. So we will try to remove that. So for here, that's the reason I have taken here equation 1, which was the value of given x. I have taken the value of y as it is. Now what we can do it, we can just simply add this equation. So what will happen, this plus uv and minus uv will get cancelled. Then left hand side x plus y, and which is equal to u. So this is how we got the value of u, which is in terms of x and y. So this is completely, so that's how we eliminated v from u, so that we can get del u by del x and del u by del y. Similarly, we have to get the value of v also in terms of x and y. So how we can get it, like this value we can substitute in equation 2, so that we can get v value also. So we know that it was given the relation y is equal to uv. This was the given relationship. In this simply I have kept the value of u, which we got it in the previous step, which was x plus y. So this is, I kept it over here. So this is how, by keeping that, I got the value of v. Now we got the value of u and we got the value of v also. So what we can do it, del u by del x we can find it, del u by del y also we can find it now, and we can substitute in the determinant. So if you differentiate this del u by del x, u's value we got it in the previous step, we got the u's value as x plus y. So simply if I differentiate this partially with respect to x, I will get 1, y का derivative 0 हो जाएगा. If I differentiate this partially with respect to y, क्या आ जाएगा यहाँ पे, then this x term will become 0, then y will be 1. So simply I got this one. Similarly, this is the v value. V value we have it here, y upon x plus y. So it will be considered as 1 upon x. और जब भी हम डिफ्रेंशिएशन करते हैं 1 upon x का, we know that it's a minus 1 by x square. So same way we will consider this one as it is. So 1 upon x y का डेरिवेटिव हो जाएगा minus 1 by x square. So this whole bracket got squared along with minus sign, and y will be considered constant because we are differentiating with respect to x. Now same way as we found del v by del x, similarly हम इसका v का differentiation partially with respect to y भी करेंगे, which will be del v by del y. So here while differentiating with respect to y, for this one we will be using quotient rule because we clearly see that it's in the form of fraction form. So we can use the quotient rule over there. Quotient rule हमें पता है, पहले तो हम जो denominator होता है वो ऐसे as it is we will write it. So we got the v's value is y upon x plus y. By using quotient rule, ये जो quotient है x plus y as it is, differentiation of numerator with respect to y 1 हो जाएगा, minus numerator as it is, differentiation of this denominator which is nothing but the 1, I will get it over here, divided by the denominator whole bracket square. So I simply use the quotient rule over here. So now I got del v by del y as well. So now after this one I can do the substitution in the determinant because all of the 4 values I have with me. The determinant which I got for j dash, उसकी वैल्यू हमें निकालनी है क्योंकि j की वैल्यू हमने निकाली है पहले ही, वो आ गई थी u, j डैश की वैल्यू हमें निकालनी है. तो हम ये वैल्यू जो भी हमने निकाले हैं वो j डैश डिटर्मिनेंट के in that we will be substituting. So here I substituted there and I got this determinant. After this we will just simplify by using determinant. So I just cross multiplied it here. This is the first term minus this term I multiplied it, and since it was already minus here, so minus minus became plus. So this is what I got it over here. So if you look at the we look at this thing, denominator, we can simply add the numerator x plus y upon x plus, and the denominator will be as it is. Denominator will be as it is. See, one bracket will get cancelled. So the final will be, we will getting 1 upon x plus y. So if you look at here, this we already know this x plus y, this was the value for u which we found it already in the previous steps. So instead of that bracket we can directly write x plus, instead of this x plus y we can write it u. So this is how we got the j dash value as 1 by u. So now what we in the question what has been asked is we have to take product of j and j dash and we have to prove it to the 1 which is equal to 1. So we simply substitute the values which we got it and it came to 1. This was our right hand side. So remember the important step, whenever it's a given implicit function we have to convert that properly so that we can take its proper differentiation, we can take it. So that's the important thing or the step which we have to keep it in mind. Else steps, writing Jacobian and writing Jacobi j dash of given function, that will remain as it is. This is how we can simplify the Jacobian numericals which are based on implicit functions. Hope it's clear. Thank you.